And a big g'day to everybody down there in East Gippsland. It's Graham Anderson here from Agriculture Victoria, just giving a bit of an overview of weather patterns and drivers of seasonal variability for East Gippsland. It's a recording of a talk I delivered to East Gippsland Beef Conference in August 2016. Now, when it comes to dealing with seasonal variability, there's probably, farmers tell me there's three key things. One is that we're needing better forecasts. The second is that actually we need to understand these forecasts. And what I'll be talking about today is around seasonal outlooks, sort of the 3 month seasonal forecasts. But irrespective of what happens with weather patterns, a key part of farming is all about managing seasonal risk and those tactics, tools and strategies that farmers use to deal with variability from one year to the next. So all of those three things are really important. And one of the good things is forecasts are getting better. We've got bigger computers, a lot more measurements from ocean and atmosphere, and a better understanding of which area of Australia is affected by which climate driver. So that's all good. Today's talk's really going to be about this climate literacy and understanding and how we interpret forecasts and when to pay attention and perhaps when not to. And farmers know all about this, and that's what farmers are good at, managing that variability. And today, I guess these sort of talks part of a national sort of project which is around helping better understand seasonal. Okay, so here's where it rained last year across Australia. This is 2015 rainfall, and you can see these colours where there was more than 600 mil or 900 mil. And just want to talk about quickly, what is it that actually the key ingredients for making rainfall? Well, there's two things we need. First of all, we need a source of moisture. You've got to have moist air. You can't get rain out of dry air. So that's one thing. You've got to have a good source of moisture, and often that moisture, it's coming from our warmer tropical oceans. But if all we ever had was moist air, it'd just be really humid. So something's got to happen for that moisture to be converted to rainfall, and basically that trigger is cold. The air's got to be cold to make that moisture fall out. And down south we get a lot of that cold air mixing with moisture, which gives us part of that really reliable rainfall. And you can see here along the divide, as moist air gets blown in onto the mountain range, that air gets lifted up. As it goes up, it gets colder and it drops out its moisture as rainfall. And it's interesting, on the leeward side of a mountain range, as air's coming over, it sinks. As it's coming down, that air actually gets warmer. It can hold more moisture, and that explains the rain shadow effect. So pretty well, in terms of making rainfall, you need a good source of moisture, and then you've got to have plenty of triggers for that to fall out. And we'll explain how in seasonal forecasting, that's where some years are a bit different from other years in terms of how. Now here we've got the same map of last year's rainfall, but this is just in deciles, and I'll just talk about deciles because I've got a few of these sort of maps. Deciles is just comparing last year's rainfall to the long-term record, and where you see decile 1, that's where rainfall was in the driest 10% of years for the long-term record. And where you see sort of decile 10, that's where records for last year's rainfall was in the wettest 10% of years. So it's just basically a way of rating last year's rainfall compared to the long-term record. So you can see down East Gippsland last year, decile 8 to 9, so certainly we're wetter than average. So you've had a really different sort of story to a lot of the western half of the state, and we'll talk a bit about that. And just looking at the winter of 2016, you can see the deciles there. Compared to other winters, there was a lot of moisture around Australia. A lot of it was decile 10, some wettest on record. Bit of the Mallee, the Wimmera was average. You can see down your part of the world it's been wetter than average. So a lot of moisture around this year, and we'll talk about where did all that moisture come from. Now, just looking at the last 2 years, you can see this is the 2014 and 15 rainfall deciles, and again you can see that East Gippsland's been a sort of average or a bit wetter, and it's been quite a different story for Western Victoria, and even parts of the west have had driest 2 year period on record. So we'll talk about that and what's been behind that. And just go back a couple of years, 2010 and 11. Two very wet years, and the Bureau sort of has that down as the wettest 2 year period in Australia's history, just pipped 1974 and 75. So a lot of moisture over all of Australia, and the key question is, where did all that moisture come from? And we'll talk about it, and it's got a lot to do with basically the mood of the oceans that and where most of the moisture is from year to year. So one thing we're going to do is have a look at some longer term records for a few sites across East Gippy. So here's Bairnsdale's it's an annual rainfall anomaly. So basically this is the long-term average line through there, and this is going back to 1880. You can see here 1880's rainfall was almost 1,000 mil, and then you can see a few years later it was only almost just over 400 mil. So a lot of variability there right through that long-term record. You can see there sort of World War II drier years, a few wetter years in the 50s, and then there's that sort of recent few years there where there's been a few above average but probably a few more drier, and a few of these sort of dry years. So lots of variability there in that record. Also, you notice how often does average rainfall happen? Average being actually right on this line of 683 mil. Well, average doesn't happen that often. So one of the things about seasonal forecasting is what is it that's behind these really wet years versus these years, and is there any indications that that farmers can take from this? This is just looking at that Bairnsdale record, but looking at the summer long-term record from 1880, the autumn, and the winter and the spring. So just looking at the different seasons, and you can see there plenty of variability amongst all of those. Possibly in a lot of southeastern Australia, we see autumns, I guess since the 80s, have probably been a little bit less reliable. Not too bad there though in recent years at Bairnsdale. Okay, now here we've got sales long-term rainfall back to 1871, and again that's plotted along the long-term average of 605 mils. So a lot of variability there. Again, you can see some sort of drier runs there, wetter in the 50s, and probably since the mid-90s, a run of dry years there at sale. So that's interesting to look at. We'll just have a look at the seasons. Here's sale, summer, autumn, winter and spring. Again, a lot of variability there. Again, autumn's probably the main season, which has been a bit more drier in the last sort of couple of decades than it has longer term. Most of the other seasons pretty variable. Spring there's probably only been one sort of wetter spring in the last 10, so that's a bit of a dry run there. Here's Omeo, so we head up the hill, and this is going back to 1880, long-term record, long-term average of 676 millimeters. Again, a lot of variability there. You can see that sort of wetter period from the 50s, and certainly that post the 50s was a lot wetter than the first half of last century. And a bit of variability there in that last few years, a few wetter years, and we'll talk about what was behind those. Omeo's variability, summer, autumn, winter and spring. Again, plenty of variability there. You can see again those autumns. The last few autumns haven't been too bad, but more broadly autumns weren't as reliable as they once were. Winter's sort of there, pretty normal, and last 3 springs there have been a bit drier. Heading out east to Genoa. So here's a long-term record, 968 millimeters, that long-term average. Here's 1891 all the way through. Plenty of variability there. You can see sort of some runs of dry years. That's all part of that natural variability out there. As we head further east, and those last few years been a bit above average. And looking at seasonal rainfall, Genoa, again, plenty of variability in that. You can't really, that autumn sort of signal's not noticeable out there. And again, those last few years, the springs seem to have been all right the last 3 years. So, and bit wetter winters as well. So, plenty of variability in that long-term pattern. Just looking at runoff down there, this is for Buchan River from 1950, so you can sort of see again those few of those decades from the 50s and 70s a bit wetter, and then it's not been as wet judging on the catchment there in the recent decades. Genoa River at the gorge since 1973. Again, you can see the wetter in the 70s and a bit dry of recent. And Erranundra since 1968. So you can see that sort of pattern. And I guess those wetter years are when the landscape's really wetted up, and so perhaps some of those big wet years haven't had a chance to shine in the more recent record. One of the things we'll talk about with East Gippsland, of course, is a key part of your annual rainfalls made up by these East Coast lows. And East Coast lows are really significant rainfall events where you can get quite a lot of rain in your annual rainfall just in a few dumps. So this is just looking at trends of number of East Coast low across Eastern Australia since 1979. You can see there that from year to year they vary quite a lot. These colours here are just the different types of East Coast lows, but a lot of variability there, and there's no really clear trend on that. There's just a lot of variability from one year to the next, but it's certainly those years where you get more of them and a bit stronger, it means that you've got a lot more chance of wetter years. But just moving beyond just East Coast lows, I guess this is just looking at these really large-scale climate drivers for East Gippsland. And so while East Coast lows might be pretty important in terms of individual weather events, what we're just going to talk about here is these really larger-scale climate drivers that affect whether southeastern Australia is likely to be wetter or drier. And you can see here, this is Antarctica. Around Antarctica, really strong winds whiz around there, and it's the conveyor belt for all these cold fronts which flick their tails across southern Australia, and that's called the southern annular mode. Really important climate driver. And some years those winds are a lot further south and the fronts are a lot weaker, and other years they're closer to us, those winds, and there's a lot more southwest activity. So sometimes when there's a lot of southwest rainfall activity, it's actually a drier for East Gippsland, so you're after it when those winds are further south quite often. In terms of moisture sources, the El Nino Southern Oscillation out here in the Pacific, these really warm oceans are really important moisture sources that feed into our weather patterns down this part of the world. And so in an El Nino year, all the warm waters out off South America, lots of cloud and rain and everything happening out there, but it means that there's sort of the moisture supply is cut off for feeding into our weather events in those years. So the El Nino and La Nina years, La Nina is when there's more moisture blowing in. This one up here is the Indian Ocean Dipole, and it's also a key influencer in it. Some years it's more useful and helping provide more moisture that feeds into our weather patterns down here. So we'll talk a little bit about these. Sometimes in our bigger droughts, when we've got an El Nino happening, not providing much moisture, and the Indian Ocean sometimes not providing much moisture, when they team up at the same time, that can make it really hard to get good rainfall years. And other times, 2010-11, why it was so wet, we had a La Nina in the Pacific, heaps of moisture blowing in from that year, and then the IOD was also when it's wetter phase. So when they both team up in their wetter phase, that means there's moisture blowing in from any direction, and any of our weather patterns down here can drag in a source of moisture when they're both sort of ripe and full of moisture. So really seasonal forecasting is just keeping an eye on what these oceans are up to, and it's the preconditions for the season. Just to give it an example, this is what a lot of the forecasters look at, and it's a sea surface temperature anomaly map. Now, normally the temperatures across the equator are like a warm bath. It's quite warm, and down here the water's really cold. But what this is showing, it's an anomaly temperature graph showing these sort of red areas of where the ocean might be 2 degrees warmer than its long-term average. So you can see here, and this is going back to September 2006, so that's what an El Nino looks like, where there's a lot of extra warmer water over here off South America. And what's happening there is usually along the equator, where the warmest water is where most of the cloud is and most of the rain and activity. And what's happening there, there'd be a heap of cloud, there'd be floods in South America, the trade winds are getting pulled backwards, and you'll notice in this area north of Australia that's cooler ocean, and actually cooler than normal, and that just means that there's less cloud in those years. New Guinea will be getting drought, and there's just less moisture feeding into our weather patterns down here. Now keep an eye on this particular area north of Australia, and we'll see what a weather pattern looks like, and we'll go to that spring of 2010 and 11. So here we go, you can see the difference here. We've got October 2010, La Nina in the Pacific, cooler water there, and all the warm water has been pushed over to our part of the world. So that means that any weather patterns happening that year have got plenty of moisture to drag in from these warmer oceans, and all the cloud and everything was over this part of the world. So that's part of what's behind seasonal forecasting, is the climatologists keep an eye on the equator to see which areas of ocean is all the moisture over our part of the world, or is it somewhere else. Now, for some of those records in East Gippsland, if we lined them up from driest year, second driest year, all the way through to the wettest, we'd end up with a third of years being wet, the wettest tercile, the driest third of years, and those in the middle. And in our long-term record, this is what we get. There's a third in each, and so what we're going to look at is for some of those sites in East Gippsland to see if in El Nino or Indian Ocean dipole years, if it changed from this normal climatology. So here's looking at that Bairnsdale record, and we're looking at Bairnsdale's rainfall here in August to November. So it's just sort of late winter and into spring. And when we look at the previous 32 El Nino events, rather than a third of those years at Bairnsdale being a dry spring, it sort of more like a bit over half of them were dry. So you can sort of see El Nino does have its influence at Bairnsdale on springs. You can see, though, that it doesn't guarantee a dry spring because 1 in 5 El Ninos was decile 8, 9, 10, so wetter. But you can see so it increases the chance of dry, it doesn't guarantee it. And in La Nina years, you can see here, La Nina years there's more moisture over Australia. El Nino years are usually drier years in Eastern Australia. At La Nina years, you can see, well, a bit of an increased chance of wetter or average. 1 in 5 La Ninas was dry, as opposed to sort of 1 in 3 compared to normal. So La Nina does certainly reduce the chance of dry years in East Gippsland at Bairnsdale. If we look at the Indian Ocean dipole, you can sort of see Indian Ocean dipole when it's in its drier phase. This is part of Australia that's a bit drier. Doesn't seem to have a huge impact on springs there at Bairnsdale from when we looked at those previous events at the August-November rainfall effect. When we look at the IOD when it's in its wetter phase, like it has been in 2016, quite a stronger driver for a Victorian rainfall. And previously, whenever the IOD's been in its wetter phase, negative IOD certainly increases the chance of average or wetter. So its fingerprints are there in that record at Bairnsdale. If we look at Omeo, when we head up the hill, El Ninos, you can see double the chance of that of a decile 1 August-November, so quite a strong driver up there. And same with the Indian Ocean dipole when it's in its dry phase. So as we head up on the range, there's more of effect of these climate drivers on that on wetter or dry springs. And La Nina effect there, rather than a third of those years being wet in La Nina years, more like 2 out of 3 are wetter. And you can see the Indian Ocean when it's in its wetter phase too. So quite a stronger effect as you head up onto the range. And when we head to sail, again, there's the El Nino effect. Its fingerprints there, drier. Perhaps not a lot of difference there on the Indian Ocean when it's in its dry phase at sail. La Nina, perhaps slightly wetter. IOD, when it's in its phase, perhaps slightly wetter. Not very strong there at sail. So it's stronger at Bairnsdale than it is at sail. And when we go to Genoa, as we head further east, basically those signals in terms of impact on August-November rainfall, pretty hard to tell there. So it's pretty much normal climatology at Genoa. So one of the things, as we head further west in Victoria and as you head up onto the range, then the impact and the seasonal sort of use of seasonal forecasting for what El Nino or La Nina or the Indian Ocean dipole's up to, it's a lot more as you head west or up on top of the hill. So that's pretty much what seasonal forecasts are about. And just like with Glenn Stevens in the Reserve Bank, I heard a farmer saying that sometimes these seasonal forecasts are a bit like getting the latest minutes of the Reserve Bank board meeting. And I guess with all that's being measured across those oceans and atmosphere from year to year, a good seasonal forecast is just giving you some heads up about, is there anything different going on this year that I need to be aware of in terms of, is there more moisture about at the moment or less? Now, our department provides monthly commentary on this through the Break newsletter. So if you're interested in getting that, it's for Victorian farmers, that.break at ecodev.vic.gov.au. And basically, we've got short YouTube updates and it's commentary on what's happening with the seasonal forecasts and for the next 3 months. And one of the things that's in the newsletter is actually this table, and it's basically looking at the different seasonal forecast models from across the world. This is the European model, that's the Bureau of Australia's Bureau model, Japanese, US, NASA. They're all got pretty clever climate forecasting systems, and this is just a table that's sort of summarising, well, what are they thinking for the next 3 months for Victoria about either the Pacific, what they're thinking about the Indian Ocean, and this year the Indian Ocean sort of on that wetter phase, and then what are they thinking about rainfall outlook for Victoria. The next 3 months likely to be more moisture around or less, and I guess for this year, there's a few of them there that I think there's a bit more moisture floating around. So that's not a bad sort of form guide that can be useful if you're interested in that sort of thing. One of the things this year, just we're talking about the Indian Ocean dipole. There's been a lot warmer water up off the coast of Sumatra here, and that warmer water, and this is a pressure anomaly map, and basically it means that there's more cloud lifting off that area, and it creates a bit of a lower pressure. And you can see here for this is from June, July this year, that lower pressure, which is the blue, that's really helped funnel a lot of that moisture in over our part of the world. And the red is high pressure region. So in El Nino years, we get a lot of the red over us, and all of the clouds out in the Pacific. Whereas you can see here the effect of that Indian Ocean dipole this year, that it's really being led by what's happening out in that part of the world. So I guess seasonal forecasting is really about a bit of a heads up about if they're picking up any sort of significant changes to normal conditions, and again, like any forecast, it's really just, it might only be once every 2 or 3 years where there's a strong signal out there that's useful for farmers. But tuning into the break will at least give you the latest on what's going on. Now, what I've talked about there has been pretty much the key drivers behind good old-fashioned variability. And what I'll talk about now is just, is there anything different going on at the moment that's anything different to long-term variability? And I guess one of the things that's talked about quite a bit is this temperature pattern, temperature story. This is from across Australia, from the Bureau. Temperatures go up and down. This is from 1910 up to last year. But certainly since the sort of 60s, that variability that we've had in temperatures has been, each decade's been warmer than the previous one. And El Ninos tend to be warmer years and La Nina cooler than average years, but even of recent times, La Nina years were just close to average, and the other years have been getting warmer. And when we look at Victoria, you can see summer, autumn, winter, spring temperatures. A lot of variability there from year to year, but you can see, summer's been warmer more often, between 1 to 2 degrees warmer, and autumn's still quite variable, but warmer years, more warmer years than the recent record. Winter's certainly been warmer. Last winter was not. It was below average, but not many below average there compared to that. Now, a lot of Victorian farmers, that's actually considered a good thing. There's a bit of extra pasture growth happening there, so that's all good. But largely the Bureau is saying at the moment we're going through a phase where we're sort of putting in an extra month of summer. So that can just mean that if we get a drier summer, then summer can be a little bit warmer and drier. This spring, what's interesting is in the last 10 years we've had a number of springs that have been between 1 and 3 degrees warmer than average. So this is sort of partly what's a bit different, and can give us a bumpy spring, especially if we're having a run of weeks where we haven't had a decent rainfall event. It can just make things dry out a bit quicker. So that's a little bit different to good old-fashioned variability. Looking at East Gippsland, down your part of the world, Gabo Island temperatures. This is minimum temperatures and maximum temperatures. Yeah, again, you can see plenty of variability in there, but just that broader trend of things being a bit warmer. Orbost, minimum temperatures, maximum temperatures, again, bit warmer in that more recent record. So that's pretty consistent with what they find in lots of parts of Australia, and it's a trend that most of the climate scientists are saying that's going to continue for the coming decades. Now, one of the things farmers ask about, temperature's one thing, but what's going to happen with rainfall? Now, this is basically a map of the climate models, where when you enter into the climate models and they spit out, if it's going to be warmer, if the world's a bit warmer, where gets more rain, and where do the models think will get less rain? And you can see here, these sort of colours is where the models say that, a warmer world, there'll be more rain. These colours are where the models are saying, warmer world, there'll be less rain. And this is where the models are unsure. But it's interesting to see that, Northern Australia, they're saying basically the models, in a warmer world, the tropics expands from the equator. There might be a bit more moisture up north, but down south they're talking about how the model's expecting things perhaps to be a bit drier. And we'll talk about, why is that? And it's interesting here, this is this sort of April to October cooler season rainfall since 1997. So that's sort of, for a lot of Victoria, been the driest run of cooler season rainfall years on record. And so I guess part of the question is, what's behind that? And I guess the climate scientists are really talking about, well, what's sort of happening here. Since the 50s, the pressure pattern over southern Australia has probably got a bit stronger. So as things get warmer, that pressure pattern was expected to get a bit stronger, and that's what's sort of been happening. And here we've got the pressure pattern. This is this region over southern Australia since 1950. The pressure goes up and down from one year to the next, and often El Nino years are when there's a higher pressure over this part of the world, and La Nina years are lower. But you can sort of see there, certainly since the mid-90s, that we haven't returned to some of those lower pressures. So this is you can see the variability in there, but behind it is this broader trend, which is sort of part of that climate change signal. As things get warmer, they expect the pressure pattern just to get a bit stronger. So that just might mean the odd year where things are a bit drier. The other thing that's a bit different to normal is, I'm not sure if there's any fishermen amongst you down there, but swordfish been popping up down around Tassie, and this is just May sea surface temperatures this year. So there's been some really warm sea surface temperatures right down even to south of Tasmania, which have been sort of 1 to 3 degrees warmer than average. So one of the things, while that's a little bit different compared to long-term variability, and where some of these fish are just swimming around following those currents, but they're turning up a lot further south. So that just means that, well, the questions of long-term variability for East Gippsland, well, how might future rainfall be if that water off the coast is a bit warmer than it's been before? It may not be a repeat of that long-term variability. And just looking at this is for March and April this year. This colour here is highest on record in terms of sea surface temperatures, but you can see some sort of highest on record this year, in April there and March. So that's one of the things that happens. Now, what can that mean? Can mean a few things. Sometimes warmer seas can mean more moisture to feed in for rainfall events, and so that's when conditions are right and the wind's blowing in the right direction, that can mean that the storms have a bit more moisture to bring in. And there's just looking at May sea surface temperature in the Tasman Sea, and you can see it's always been variable, but this year it just shows how much warmer it's been this year. So it's been quite an extraordinary bit of warm water poking around down there this year. So one of the things is, well, how might that affect East Coast lows? If you repeated the last 100 years of East Coast lows, but you sat them over water that was a lot warmer, will we get a different result? And it's interesting just looking at this long-term variability in East Coast lows since 1979. I've just plunked on there the El Nino years, and you can see 2006 was an El Nino year, certainly suppressed the number of East Coast lows, and 82 was a famous El Nino year, and again it suppressed the number of East Coast lows. And these other El Nino years, it probably suppressed a few events, squeezed a few out when there was a higher pressure around, but not always. You can see that was an El Nino year in 2009, and there were plenty of East Coast lows there. But I guess one of the things is, what happens with East Coast lows in future. We've got this thing about the warmer water off the coast, but there's also this issue of the higher pressure. So what does that mean for East Coast lows? And I guess just, I've spoken to a few scientists about this and about, well, okay, so we get East Coast lows, they're important moisture source and rain events in East Gippsland. So what might the higher pressure mean? And so, well, on one hand, the higher pressure over southern Australia could make some events weaker, or perhaps when they do happen might have a bit less rain because they're happening under a higher pressure. So that sort of means that occasionally we might miss out on the odd East Coast low, or they mightn't deliver as much rain as we'd want. But the other hand, when we've got warmer seas out off East Gippsland, that can actually help stoke some extra moisture and strength. And so when conditions are right, and you've got a good East Coast low that's stoked up, sitting on warmer ocean, you can bring in a bit extra moisture. So I'm saying, well, that's one sort of suggesting it might be occasionally a bit dry, and the other says there's the potential for it to be a bit wetter. And knowing Mother Nature, probably we're going to get a bit of both. So I guess in terms of what's the practical thing for farmers, it's just really planning to deal with, if anything, a bit more variability. So making sure that there's a few more tricks up your sleeve for dealing with warmer and drier conditions occasionally, but also there'll still be some pretty wet conditions as well. Good old-fashioned variability mixed in with a few surprises, I guess. And it's also interesting, this is just some work done recently by David Stevens from AGIC, but basically talking about looking at the seasonality of Australia's rainfall, looked at long-term seasonality, and then what's happened since 2000 to 2015. So this is basically, summer dominant rainfall patterns, or whether it's uniform throughout the year or winter dominant. And basically showing that the rainfall pattern since 2000, that seasonality has largely shifted south. And I guess that's a good way to think about it, is that largely our weather patterns and climate zones are shifting south, and they're migrating south, and that's probably going to continue. And there's some pros and cons in amongst all of that, but I know that there's profitable agriculture happening in all of these climate zones across Australia. So climate zone doesn't determine how well agriculture performs, but I guess what it just does mean is that if the seasons and climate in your particular area are changing a little bit, it just means that, well, what is it we do to manage that so that we're still profitable in our enterprise? But that's a pretty good way to think about it. There's usually just these climate zones that are gradually just shifting south. And talking about all the things that farmers are doing, it's been pretty amazing amongst the last couple of decades. Agriculture's been, we've thrown plenty of curveballs from the weather point of view, but actually, we're growing our exports and growing the amount of food that farmers are producing, and doing all of this through, modern technologies, better equipment, better genetics and system. And it's really fantastic how modern agriculture is so good at producing things. So that's great, and that's got to continue. Also, what's really important in dealing with seasonal variability and climate is just improved farm and regional infrastructure. So the improvements in storage, whether it's for water or fodder, also communications and roading, and all of those things are really important, which help us for how we deal with sort of whether they're bigger dries or bigger wets. Growth in local and export markets has really been a key part that underpins successful and profitable agriculture, and so making sure we're managing biosecurity risks and all of that's really important. And farm planning, soil health, pasture cover, natural resource management skills, and land care, that's been a really big change. And basically, a lot of damage is done when we're to our farm soils, either at the driest part of the cycle or the wettest part of the cycle. So, good farm planning has been a really key thing to make sure that our soils don't get damaged when we're being battered by climate extremes. And this is a really key one, this business management for variable years and income. And I guess that when the seasonal conditions are right and we're getting good prices, we can probably make more money in agriculture than ever before. But also, with a few years later, you can find that, well, with some tough years and high costs, and if markets are low, then we can actually probably lose more. So it's really important that business management to deal with increasing variability of income is going to be an even more important part of agriculture. It always has been, but it's probably going to be increasingly. And it's all of those things are about helping this flex with greater variability, but we're still really, if we do that well, we can adapt and grow agriculture in future. So I know East Gippsland farmers have been doing a great job because it's quite a variable climate down there, and I guess it's it's keep making improvements from one drought to the next, which actually set us up to ride through them a lot better. So I hope that's a quick overview of weather and for East Gippsland. If you're interested, drop an email to the break at ecodev.vic.gov.au. We can add you to those monthly newsletters, and there's YouTube updates on that as well. So or any queries, drop me an email. All the best.